Okay, so we're going to start by talking about insertion sort. Um, so before we get into what insertion sort is and the code for it, the pseudocode for it, let's first discuss sorting. So one of the primary things about computer science is our basic data structure. We commonly use arrays, and arrays are just a collection of items, whether that be integers or decimal numbers or strings, things like that. And a big question is, well, how do we sort that collection? If we have a collection of numbers, usually it's nice to have that collection of numbers in sorted order from lowest to highest, because there's a lot of things that we can do with that. When it's just a random mismatch of numbers, that doesn't help us too much. So insertion sort is one of the many algorithms there is to sort an array. We'll be discussing more types of sorts later on in this lesson, but for this particular moment, we're going to be discussing insertion sort. So the input to this algorithm is an array of n integers. I suppose it could be strings or characters or doubles or things like that, but for now we'll just assume it's integers and we have n of them. And the output of our algorithm will be the same array, but in increasing sorted order. So that means something like, if we start out with an array of 3, 2, 7, after calling the algorithm, it will return 2, 3, 7. So the array is in sorted order. And an important thing about this is that it sorts the numbers in place. So this algorithm sorts it in place. What that means is that the algorithm doesn't create any new array and then copy the contents of the old array into the new array. What happens is that this array, this actual structure, stays the same. It's just the elements within it sometimes get swapped around. So that's what we mean by in place. There's no new data structure that's being created in the algorithm. So let's take a look at the pseudocode for it. So insertion sort on A. So we start with a for loop that goes from index 1 to the length of the array. I guess we'll do up until the length of the array minus 1. So we'll assume 0 indexing, which means the first element of the array is at index 0. So we're going to start at 1 and go to the length minus 1, which would be the last element of our array. Okay. So then inside of our for loop, we're going to declare a variable called our key. And the key is kind of going to be a pointer of sorts. We'll see it in an example. But the idea is that we're going to insert our key into the sorted sequence that's the array from indices 0 to j minus 1. So if our key is at index j, we're going to put it somewhere before it, and we're going to be under the assumption that everything before it is in sorted order. So what that means is we have to consistently sort all elements before it. Okay, so this comment is for the rest of the code. So the rest of the code is going to be doing that sorting or insertion. So we have another variable called I, and that's going to start at j minus 1. So I can be thought of as another pointer, and that's just pointing to the element right before our key. Then we have a while loop, and the conditions for the while loop is that I must be greater than or equal to 0, and the value at I has to be greater than the key. Okay, so those are our conditions. If that's the case, then we're going to essentially assign a value in our array to the previous value. So we're shifting everything over as long as these values are greater than our key. So we shift AI to AI plus 1, and then we decrease our pointer by 1. And then we check again, do these conditions hold? If so, we shift A sub I, or A of I to A of I plus 1, and decrease the pointer. And we keep on doing that until we're pointing at a value that's not greater than the key, or our other pointer has already gone to the first point in the array. In that instance, we will take whatever we're pointing at, the next element, and set that equal to key. So it's kind of difficult to visualize it with just this code here. So let's just sort of walk through an example. So, okay, we have this array here. That's what we're going to start with, and we're going to try to sort this using insertion sort. So I'll try to keep the algorithm and the array visible, but it's going to be difficult too because I'll have to scroll up and down. Okay, so we start with j, which begins at 1. So we'll have a pointer here, which we'll call j. And then we have a value key, which, like, we're inside of the loop now. Key gets assigned a of j, so key starts at 2. So then we have I, which is assigned to j minus 1, so that's another pointer, and that's pointing to the element right before it. So then we go within our while loop. Is I greater than or equal to 0? Yes, it is at index 0. Keep in mind that this isn't what I is pointing to, this is the actual index of I. So I is at index 0, so that holds true. And is the value of I, or is the value at I greater than key? Well, the value at I is 4, which is greater than 2, so both of these conditions in the while loop hold, so we have to move in here. So we want to set a of I plus 1 to a of I. So let's just scroll down here. So a of I plus 1 would be this box right there, since I is currently at 0. And we want to set this equal to a of I. So a of I is 4. So we'll put a 4 here. And then we're going to decrease I by 1. So, whoa, what's going on? Okay. So we're going to take this pointer, that is I, and we're going to shift it over 1. Okay, so we finished one iteration of the while loop. Now let's check again. Is I greater than or equal to 0? No, it's like -1 now. It's pointing outside of our array. So this condition doesn't hold, so we don't do this. And then we set a of I plus 1 equal to key. So a of I plus 1, if I is -1 right now, a of I plus 1 is 0. So a of 0, so this element right here should be equal to key, which we said was 2. Okay? So that finishes the first round of this for loop. So now j would increase to 2. So let's just fill in the rest of the array here. Everything else stays the same. Okay, great. So now let's do another iteration of the for loop. So now j is equal to 2. So we have a pointer j, which is now here, index 0, 1, 2. So that's that. Scroll back up. We'll set the value of key, which is the value at where j is pointing. So key in this case is 6. The next step is we set our pointer I, which is the element right before it. And then we do the thing where we check, is I greater than or equal to 0, and is the value at I greater than key? Yes, it's greater than or equal to 0, but the value is not, I is greater than or equal to 0, but the value is not greater than key. So we do not execute this while loop. And instead what we do is we set a of I plus 1 equal to key. So a of I plus 1 would be this box right here, and key would be 6. So let's just write that down here. And then everything else stays the same. So in between these two iterations, nothing really changed at all. From here to here, it's the same exact array. Okay, let's continue onwards. So now we're do another iteration of the for loop. So I won't go back to the code now. I hope we kind of understand it. I'll sort of just walk through it quicker now. So j now points to here. Our key is equal to 1. And we have this pointer, which is I. So now we enter the while loop. I is greater than or equal to 0. and the key at, or the value at I is greater than our key. So what that means is we're going to assign the value in the box that's 1 greater than I. We're going to assign that to what I is currently pointing at, which is 6. So up here, we'll give this a 6. And then we're going to shift I down by 1. And then we do the check again. I is greater than or equal to 0, and this is greater than this. So we're going to assign this box to what I is pointing to, which is 4. Good. Shift I down once again. I, once again, is greater than or equal to 0. This is greater than this. So we will set this box equal to what I is pointing to, which is a 2. Okay, and then we shift I down once more, and now we can't continue with the while loop because I is not greater than or equal to 0. So we exit the while loop, and that means we set the value at a of I plus 1 equal to key. So a of I plus 1 would be this box, and our key is 1. So we put that here, and then we finished the for loop, so everything else in the array stays the same. All right, just a couple more iterations of it. So we do another iteration of the for loop. This is j. Our key now is 3. And then we have our pointer I. This is not greater than this, so we don't do anything. Well, rather, this is greater than this, so we set the value in the box here to what I is currently pointing at. I don't know where my pointer went. Right? So we're going to set this box equal to this. So we'll do that. And then we shift I down by 1. I points here. Again, 4 is greater than 3. So we set the following box equal to what I is pointing at. So this is a 4. Okay. And then here things get a little bit different. I is greater than or equal to 0, but it's pointing to 2, and 2 is less than 3. So we escape the while loop, and we set a of I plus 1 equal to key. So a of I plus 1 would be this box, and key is 3. So we put a 3 down there, and then everything else follows with it. 1, 2, 5. And then we have one more iteration to do because j goes up to the length of the array minus 1. So j is here. Our key is 5. This is I. And then we check. Okay, I is greater than or equal to 0. 6 is greater than 5. So we set this box equal to 6. So that's a 6. Shift down the pointer by 1. I is greater than or equal to 0, but now 4 is less than 5, so we escape the while loop, and then we set a of I plus 1 equal to key. So a of I plus 1 would be this box right here, and our key is 5. So we set this equal to 5, and then everything else follows suit. And we see that, okay, now we have finished sorting the array. We finished the for loop because j got to its maximum position, and sure enough, we are in sorted order. But the thing that we really want to see, like what's going on here, is what's going on is we're taking a value that we're pointing at, and we're just putting it wherever it belongs before it, right? So first we started with a 2, that was our important value, and if we look at everything before it, 2 should come before 4, right? So we put it before 4. So this part is sorted, right? Then we increase our pointer. We looked at 6. And then amongst this sorted set, 6 belongs after the 4. So that's where we put it. And we were left with this set of 3. And again, this 2, 4, 6, that's in sorted order. Then 1 became our important value. Where does 1 belong? It belongs in the very front of all of this. So that's what we get here. Again, 1, 2, 4, 6 in sorted order. We look at the 3. Where does this belong? That belongs in between the 2 and the 4. So now we get this set of 5. And then we look at our 5. Where does this belong? In between the 4 and the 6. And that's what goes there. So the best way of thinking about insertion sort is sort of like you're sorting a hand of cards. If you have a bunch of cards, like the way we typically sort it is we like have some cards that are already sorted, then we take another card that we want to put in the sort, and we just figure out, oh, where does it belong in my hand? It belongs in between these two cards, that's where I'll put it. That's exactly what insertion sort is doing. So that is the first type of sort that we'll look at.